Today, I am going to be talking about a new technique that is going to change the world. And that new technique is called neural rank. Neural rank is going to change how we seek and find information, especially when we're looking for information that might be covered in many different languages. So before I start, I want to show you a number. This number that you see on the screen. I want you to look at my face, look at the number, and try to read my thoughts. And I'm sending to you from my brain now, I'm sending brain waves that have the meaning of this number. I'm going to give you 10 seconds to receive the brain waves and tell me, what does this number mean? What is this number for? Of course, that's not going to work. Nobody's going to be able to read my brain. We as humans, our ancestors many decades ago, figured out that we can't simply have thoughts go from one person's brain to another person's brain. I mean, that would be very efficient if we could do that. And in fact, as you might know, Elon Musk is working on something called Neuralink. Neuralink, you can think of it eventually in the very far future, it would be a cell phone in our brain. And it will let our neural network, our brain, speak from one brain to another without having to use words. But we don't have that today. And our ancestors did not have that 10,000 years ago, 100,000 years ago. So they came up with language. They came up with languages, many, many languages. What you see on the screen right here, the 6543, that is the number of languages that exist in the world. I want to best do a quick check. You can see my screen fine, right? The presentation, because I can't see the stream right now, so I'm not sure if it's working or not. You can see the number fine, right? There is a significant delay. I'm going to assume the answer is yes. So yeah, there you go. I see many yeses now coming. Thank you. Thank you. So yes, so going back, 6543, that is roughly the number of languages that exist in the world today. We came up with 6,543 languages so we can speak with each other. It's insane. It's an insane number of languages. And the reason why is, again, it goes back to our ancestors. ربنا يسامحهم. They form groups and they want to talk to each other, but they don't want the people around them to know what they're saying. So they come up with a new language. Essentially, it's encryption by coming up with new languages and different languages. And that is what led to this very big number of languages that we have in the world today, which is a problem. It's a problem because I'm speaking to you in English right now. Alhamdulillah, you understand English. But if I switch to Chinese or Spanish or Italian, you're not going to understand what I'm saying. And there's so many languages out there. And we're not getting the knowledge from all of these languages because we are seeing only a subset and finding only a subset of these languages when we search online. So now I'm going to shift the topic a little bit from the topic of languages to the topic of search and how we do search. And then I'll come back and tie that back to languages in a few seconds. We do search today. Most search engines, whether that be Google for the web or whatever search engine you're using inside of your company, they do what's called keyword search, as you can see on the screen. But keyword search, it fails. It always fails. And the reason why keyword search fails is because of these problems that you can see here that I'm going to illustrate in the next couple of slides. So for example, one second, I'm trying to get my pointer. I can see the pointer. There's no pointer, that's fine. I assume you can see my mouse. So for example, keyword search does not take into account the order of words. It does not take account that there's multiple meanings of a given word. And it doesn't take into account that there's multiple words with the same meaning. It tries to fake all of these kind of things, and I'll show you how it tries to fake it. But it still fails at doing that. Man kills bull has a very different meaning from bull kills man. I hope we know that, right? When we see a sentence like that, we know. But when you're doing keyword search, you're going to match documents that have the words man kills bull or bull kills man, unless you put quotes around them, and very few users do that quotes thing. But the sequence should tell us what we're looking for. We don't need the codes. Another example of how keyword search fails. Another example of how keyword search fails is it doesn't understand part of whole relationships. So if we say arm got injured, this will not match a document that has the text hand and elbow were wounded. Because first, maybe injured and wounded, we can do what's called the aliases to find that. But arm is not an alias for hand or elbow. On the contrary, hand and elbow are elements that make up the arm. And normal keyword search will not match a result like this. It will not find it for you. Furthermore, different words can have different meanings, like you can see here. Oleg led innovation. Oleg is actually the name of the inventor of the LED, the light emitting diode, LED. But LED, as you know, also is the past tense of the verb lead. So if you are speaking with a human, they will understand, hopefully, that Oleg now, we're talking about the LED, the light emitting diode. But if we're just matching, then you will match documents that have the verb led in the past tense, where somebody called Oleg was leading invention in some company. But that's not like really what you're looking for. You're looking for the lead. So these are examples of how keyword search fails. Next, we have PageRank. PageRank is an algorithm that you might be very familiar with that Google came up with about 20 years ago, 22 years ago. And PageRank improved keyword search significantly because what PageRank did, it looked at the links between pages. And for example, if we have links going to the Tabuk University, and we have awesome university, awesome university, awesome university, awesome university, awesome university, and all of these links are linking to Tabuk University, then now when somebody searches for awesome university, Tabuk University shows up high in the results because everybody's voting with the links to it that it's a good university and it's an awesome university. And that works and worked back then when Google came into existence because we had very small number of documents on the internet. We had a very small number of content, and hence the links were sufficient to do that kind of stuff. But that was a couple of decades ago. Today, we have tons of content on the internet, not just in English, in many, many other languages. And we have a very, very long tail for that distribution. We have a lot of content that doesn't have links coming into it. And hence PageRank is not able to give us good results. And the SEO spammers, the search engine optimization spammers know that, and they game that. They go, for example, if you know you love sailing, they go and they create all of these links saying sailing, 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 sailing on many, many pages on the web. And all of these links are pointing to a page where there's an NFT of a boat. NFT is the new way of buying art right now, just because they want you to buy the art from them. But it has nothing to do with sailing, and that's how they trick you into finding them. Last but not least, and this is really the biggest problem, keyword search simply does not work across languages. I'm sorry, I had a Spanish dish example here, but I'm going to use an Arabic example instead. Say you search in English, you search in English for how to cook mulukhiyya. Okay, how to cook mulukhiyya. We just put that as a search string in Google. You're going to get the best search results on how to cook mulukhiyya from the cook, from a master chef, maybe in the US or in Canada or in Australia. But we all know mulukhiyya was invented, I think in Egypt. Mulukhiyya was, maybe not, but somewhere in the Middle East, mulukhiyya was invented. And somewhere in the Middle East, somebody wrote the authentic article, the best article about how to make a mulukhiyya, but they wrote it in Arabic. And because you didn't say, كيف أطبخ الملوخية بالعربي, instead you said, how to cook mulukhiyya in English and using writing mulukhiyya in English, you're not going to get that result because keyword search is trying to match the English to the English and it doesn't know how to cross languages, which is a very big problem. Again, that wasn't a very big problem a couple of decades ago when we didn't have that much content from other languages. It was all English anyway on the internet. But today we have all kinds of content from all kinds of languages that we're not seeing because of this limitation. So these are the problems for keyword search. Hopefully I convinced you that there is a problem. I assume some of you are already facing these problems and aware of these problems as well. So now I'm going to go very quickly just to illustrate why keyword search is failing and how we tried to improve it over the last couple of decades. Like these are techniques that Google is doing, but other companies like Elasticsearch or other kind of enterprise search companies are trying to do as well. So the first thing you do when you have a sentence like this, dog adoptions in Silicon Valley. If you want to get good search results, the first thing you do is you'll notice that the word in is available in almost every document. So we say in, which is known as a stop word, has very low information content. And hence, one of the very first things that we do in keyword search is we throw away in, even though it's important, by the way, and it's useful, because dog adoptions in Silicon Valley is very different than Silicon Valley full of dogs or something like that, right? So the sequencing and the usefulness of in is lost when we do that. But that's what we do today with keyword search. We just throw the in away. The next thing we do is we get the roots of words. So you can see adopt and adoptions. يعني بنروح للأصل الكلمة الجذر بتاع الكلمة يعني عشان so that we can find more results. So instead of saying adoptions, we say adopt, right? We get to the roots of the words. That's called stemming, and that improves the recall and improves how much results we're trying to find. And then next we do what's called term expansion, where we look at aliases or other ways where we can say a word. For example, dog. And this is where the knowledge graph comes in. If you hear about the concept of knowledge graph, is to maintain these kind of different ways of saying things or relationships between terms and each other. So a bulldog, a collie, a beagle, a Maltese, a husky, a pomsky, they all belong to the family of dog. So we can add all of these aliases in there. Same thing, Silicon Valley can be inside of Silicon Valley. You have San Jose, you have Mountain View, you have Sunnyvale, you have Cupertino, which is all belonging to Silicon Valley. So now if I want to increase the recall and find better results, I have to do all of combinations of Bulldog, adopt, and then Mountain View, and then Bulldog, adopt, and then Sunnyvale, and then Bulldog, adopt, and then Cupertino, and then Beagle, adopt, you see what I mean, right? And we run all of these query strings to try and get what the user is looking for, which obviously is not very efficient. Not only is it not very efficient, it's actually, it returns bad results every now and then, because this will still match good hot dogs in Silicon Valley or good hot dogs in Cupertino, which absolutely is not what you're looking for when you're doing such a query. So how do we fix that? Fixing that is very expensive. Very few companies in the world are able to fix that, and they're fixing that with neural search, right? They're doing neural network techniques that are a lot more advanced than the normal keyword search techniques. Most search companies out there, with the exception of a few, are still doing keyword search, and the costs of maintaining that keyword search to increase the quality, as you can see in this chart, where you have the quality is down on the x-axis and the cost and complexity is the y-axis, it only goes up as we try to improve it, because we have to build these massive knowledge graphs with all the aliases and all the different variations and relationships between things. And we have to have an army of humans actually maintaining these knowledge graphs, which is extremely hard to do. So very few companies in the world are able to do this until now. Something very important happened a few years ago that is changing everything. And before I show you that, I want to describe it to you, and then I want to show it to you, and then I'm going to explain it to you. First, the technique is called neural rank. Neural information retrieval, neural search, in other words, via a neural network that digests all human languages and knowledge into a unified neural semantic representation, UNSR, which you can pronounce as answer. And it can answer everything and anything. And the answer is not 42 for the sci-fi geeks around you. The answer is more and much more different than 42. So now let me show you a quick demo to demonstrate what I'm looking for, what I mean here by how keyword search is not working. And I'm sorry, I keep looking right because the text chat is coming here, so I'm just looking if there's any problems. That's why I'm doing that. So please forgive me, and I'll try to talk slower. I saw a couple of messages on that. So I just drank some coffee to stay awake, so that's why I'm going fast. If you go to Amazon, this is an Amazon web search page, sorry, an Amazon product page for a router. This is the router, okay? It's a Netgear router. And we're going to the customer reviews of that page, and we're doing a search for, can I stop my child from using the internet? I'm gonna increase the font a bit so you can follow along with me. Let me do that. So I'm searching for, can I stop my child from using the internet? Look at this, it's matching the keyword internet, internet, internet. Nothing about children, nothing about firewall, nothing about stopping my kids, because it's doing keyword search and it doesn't go to the essence of what I mean and what I need. Here is how neural search would do it. This is a product that the company I'm in has built. And I'm gonna take this query, can I stop my child from using the internet? I am gonna paste that query here. And look at this. I'm going to increase the font so you can read along with me. I am not a parent, but I see they have a ton of settings for parents to block websites or keywords, and also limit connection time and pause resume the internet to specific connection at the tap of a finger, which is exactly what I was looking for. Another result that came, there is no way to block social time wasting sites at night for your children's devices. So maybe you can say, okay, children down here, child up there, matched on that, but there's no internet in this sentence. In fact, let me change child here to be, can I stop my kid from using the internet? I like being able to disable the internet when my son plays video games. It's still giving you good results. And here is the magic. Not only is this neural technique understanding what you want, understanding the essence, it can do it across languages. It learned how to digest all languages. The 6,000 languages right now doesn't support all languages, but it learned how to digest all of them into one language that the computer truly understands. We cannot understand that language, but the computer understands it very, very well. So now I'm going to take this query and I'm going to go to Google Translate and I'm going to translate this query from English to Arabic because many of you understand Arabic. هل يمكنني منع طفلي من استخدام الإنترنت? That's the right translation. I'm going to copy that. I'm going to go back here. I'm going to put my query. I get back the proper results. There is no way to block social time wasting at night for your children's devices. But if you want something control when your kids are online, you might want to look for something else. It's giving you the right results. I'm going to go back here. I'm going to take it Chinese. Hopefully there's some Chinese among you that can validate this is the right Chinese. I'm going to copy the Chinese. I'm going to go back here. I'm going to search. Again, I get good results. And by the way, this demo is live. You can go to the site and try it out. If you just go to the URL, I'm going to put later in the talk, but you can see it up here on the screen. You can try this demo out yourself. It supports many languages. I can go back here. I can do, I think I'm now belaboring the same point, but let's go to, for example, French. Some of you might be speaking French. There you go. This is the query in French. I don't know if it's the right translation from Google. I'm going to take that, go back to this neural search engine that understands every language. I'm going to put it here, and I'm getting good results still. Because it's not searching by language. It's taking the language, it's mapping the language to the meaning, it's searching by meaning. And that's why it finds these things. This is another example here. I'm not going to show it to you in detail, but this is a site called Farfetch that has many languages in the comments and the reviews. It's not just in English, to show you that even if you put in English, you're going to get back results in many languages in response to the English. Some of them are English, many of them are not. So this query here was, what kind of material is this dress made from? The photographs made this look either a fully lined dress or opaque fabric. That's the right answer. We have something in Chinese here. Let's look what that means. I'm going to take that. I'm going to go back here. I'm going to put it here. The language is detected as Chinese. I'm going to translate that to English so we can read it. There is also a lot of thread at the junction of the skirt. I can't believe this dress I bought for 12,000 RMBs. It found the right answer across languages, even when we have many language to many language. I can take the same query and do it in Arabic, it would still work. But I need to go back to my presentation to explain to you how this works. So I give you the technical term, the technical technique, which is a neural information retrieval system that uses neural networks to digest all human language and knowledge into a unified neural semantic representation that can answer everything. The layman words, that the way I explained this to Mama or Baba, when I talk to Mama or Baba, I would tell them this. Neural rank, okay, that's going to be a hard word for them, but it becomes easy after that. Enables computers to map all human knowledge and languages into a universal data brain inside the neural network. That data brain can truly understand the essence of what we seek while removing languages as a barrier between us. So no longer is the 6,543 languages out there a problem, because the computer unifies us and allows us to find results across all of these languages. This stuff was not possible. This stuff was not possible until this decade that we're in right now. In the 2010s, we couldn't do this. In the 2010s, we had a technique called one-hot vectors, where we would take every word in the English language, we would map it to a vector, where that vector only has one of the bits is 1 and everything else is 0. And then the neural network learns based on that. And that obviously doesn't work because it lacked continuity. It didn't show you that king and queen were related and that king and queen are similar. They're not exactly the same, but they're close by in proximity, in meaning. Until a very genius step happened. There's 3 events that happened. I'm going to go over the 3 events. The first event happened in 2013. In 2013, the concept of word vectors was introduced. What the word vectors said is, no, don't just put 1 in one of the points of that array. Instead, build a geometric vector, and it's a multi-dimensional vector. It's not just 3 dimensions as this picture you can see here. And inside of that vector, we have vector 1, vector 2, vector 3, vector 4, all of these pointers inside of that vector space. Put the king and the queen beside each other because they're related. It's kind of what we do in our brain as well when we're retaining these concepts. We keep the concepts similar to each other, closer to each other, because that's how that makes sense. So that was the first kind of advancement that moved us in this direction of being able to solve this problem and build a computer neural network that can comprehend and understand just as good as humans can. The next evolution happened with event number 2 in 2017. This did not exist before 2017, which is just 5 years ago. Is that we figured out the technique that's called transformers. And I invite you to go read the paper, Attention is All You Need, to learn more about transformers, or search online for on YouTube for Transformers Explained. And you can see many videos explaining transformers. But in a nutshell, transformers was one of the biggest changes in how we can get computers to comprehend. It led to a 27% increase in the F1 score of how we measure the efficacy of these techniques. Versus normally, we would only get things on the improvement on the order of 0.1%, 0.2% historically. Before 2017, we could only advance these things very, very little. And then transformers came in and just went up by 27%, just like that, in terms of how much more it's able to comprehend. And one of the very first applications of this, you can go check this great product called Google Talk to Books, which indexed a lot of books, and it can answer questions about the books just like a human would read and answer you if you were to ask the human questions about these books. My co-founder at Zier was one of the creators of that product, which you can go try. And then the last technique, and I'm almost done with my presentation. I see I'm approaching my end of my time. The last technique, which was a very, very key technique as well to making this really work, is unsupervised pre-training. If you look at us humans, we don't learn every domain and every context from scratch. If I understand Arabic or if I understand English and read a medical paper, even though I am not a doctor, I can still understand some stuff, right? There will be some terms, like a special term for a disease that I might not know, but on average, I will roughly understand what's going on because I have a pre-training in my brain that allows me to do that. Computers did not have that until 2018. That's only 3 years ago. Only 3 years ago, we discovered the technique that allows computers not only to understand relationships between words, which is important, not only to understand sequence between words. When I say man kills bull, it's very different than bull kills man, but now it retains its understanding so that when it's learning something new, it does not start from scratch. It starts from where it stopped. And that led to a very significant improvement in how we do things. I invite you to go read the BERT paper, which was published in 2018 and describes how to manifest that and how to implement that. There is some drawbacks for that technique, which is to do a search in an index space like this. It's in the order n complexity, which is not very good for searching the web. If you want to search the entire web, you don't want to be order n. And it's very, very CPU intensive to build. Whoever figures out how to make this cheap to do will be in a very good place. Let me just put it at that. Now I'm going to end with my last slide, which is, okay, how are we going to use this? How is this useful? What can we do if we have this neural network that can speak across, that can understand the essence of queries across languages? What can we do with that? So the first thing is enterprise search. Enterprise search is when you're searching inside the documents of the University of Tabuk, for example, or inside any organization. You don't have PageRank. You don't have enough information to rank things properly. You need something like this. You need an algorithm that's truly comprehending the articles and matching that comprehension to what the user is looking for to get good results. Today, employees in most organizations waste between 20% to 40% of their time looking for stuff, right? They have to click, 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 click until they find what they're looking for. And sometimes they end up recreating stuff that already exists because they couldn't find it, which is even more wasteful. Second, e-commerce search. I already showed you a demo of that with the Amazon product search. Third is content management systems like WordPress, Atlassian, Notion. They need a capability like this. Fourth, litigation search. And I'm only going to stop with 5. I'm not going to go through the whole list. Don't worry. Fourth is litigation search. When you're doing a legal investigation within a company and looking about emails and documents where there might be an infringement from one company to another, now the companies are global. They have documents in Arabic. They have documents in English. They have documents in Spanish. They have documents in Italian. It's very hard to do these litigation searches. With an engine like this, you do it in a second. And not only do you do it a second across languages, it does it with all the proper nuances. If I'm looking for a man who injured his arm, I will still get a result that said that man had electricity that passed from their hand to their elbow, and they got wounded. There's no word injured. There's no word arm, yet it matches. Prior art search. I'm going to end with this one. My brother, his name is Ahmad Awadallah. Ahmad, my brother, I'm Amr Awadallah, so my brother naturally is Ahmad Awadallah. Ahmad Awadallah is a professor in Qatar University. He teaches economics, and especially he teaches auditing and accounting. And he's doing a research paper on accounting failures of the big firms, how the big auditing firms, the big four, have some accounting failures, but he was looking specifically for accounting failures in China and Brazil, where we know there has been a number of really big failures that happened over the last couple of years in these countries. He's searching in English. He's getting no results. He's not getting the perfect Chinese paper that describes exactly how Evergreen had an auditing failure. He's not getting the perfect Portuguese paper in Brazil describing how one of the companies over there had a big auditing failure, because he's searching in English and these articles were written in Arabic. Sorry, in Portuguese or Chinese. I said in Arabic. So to conclude, the future of neural search, the future is of where we're going, is having the capability to issue queries in any language, truly understand the essence, the meaning in our brains, not the words that we added to be able to talk to each other. We added these words. There's an essence inside of here. It understands that essence and it matches essence to essence, and nothing can beat that. Thank you. That's my talk.